Hello everyone. Today we are going to analyze this fixed beam. In this beam there is a uniformly distributed load 60 kN per meter. It acts in the left half and there is a concentrated movement 160. It is acting at a distance of 2 meter from the right support and it is acting in the clockwise direction. To find the fixed end moments in the points A and B, we are going to use formulas. If in the fixed beam, uniformly distributed load is acting left half, the formulas to find the fixed end moments are 11 WL square upon 192 and 5 WL square upon 192. In the point A, the moment will be acting in the anticlockwise direction, and in the point B, the moment will be acting in the clockwise direction. If in the fixed beam, there is a eccentric concentrated movement M, and it is acting in the clockwise direction, these are the formulas to find the fixed end moments. Initially, we have to assume that both of the movements are acting in the clockwise direction. If we get any negative value, that means our assumption is incorrect. The movement is actually acting in the anticlockwise direction. First, let us consider the uniformly distributed load 60 kN per meter. We have seen both of these two formulas. Let us keep the anticlockwise movement as negative and the clockwise movement as positive. Let us apply the values in the formulas. W is 60 and L is 8. Let us apply them. Now let us take the concentrated movement 160. We have seen both of these two formulas. We know that we have to assume both of the movements are acting in the clockwise direction. So both of the formulas should be applied as positive. Let us apply the values. M is 160, A is 6, B is 2. When we calculate this, we will get minus 220. When we calculate this, we will get 100. When we calculate this, we will get positive 50. When we calculate this, we will get minus 30. That means the assumed direction is incorrect. To get MA, we have to add these two values. When we add, we will get a negative value. That means MA is acting in the anticlockwise direction. To get MB, we have to add these two values. We will get a positive value. That means MB is acting in the clockwise direction. Now let us take a moment about B and find the vertical reaction RA. MA is acting in the anticlockwise direction so that it will be negative. RA is acting in the clockwise direction so that it will be positive and the distance is 8, so 8 RA. The uniformly distributed load is acting in the anticlockwise direction so that it will be negative and then we have to multiply the distance 4. Then we have to open a bracket. Then we have to divide the distance 4 by 2 and then we have to add the remaining distance which is also 4. The moment 160 is acting in the clockwise direction so that it will be positive. The moment MB is also acting in the clockwise direction so that it is also positive. For RA, we will get 172.5 kN. By applying the rule sigma V is equal to 0, we can find RB. Here you can see the shear force calculations. Here you can see the shear force diagram. In this point, the shear force becomes 0. Under the uniformly distributed load, in this point, there will be maximum positive bending moment. In this point, let us make a section and find the distance. You can see that I have made a section at a distance of x from the point A. We know that in this section, the shear force is 0. Using that concept, we can find x. Now, under the uniformly distributed load, let us find the maximum positive bending moment. MA is acting in the anticlockwise direction, so that it will be negative. RA is acting in the clockwise direction, so that it will be positive, and the distance is 2.875. The uniformly distributed load is acting in the anticlockwise direction, so that it will be negative. We know that with the uniformly distributed load, we have to multiply the distance and the distance by 2. Finally, we will get 77.97. Now let us find the moment in the point A. In the point A, we have MA, which is acting in the anticlockwise direction, so that it will be negative. In the similar way, we can find the bending moment at C. To find the moments in the point B and the point D, we can follow left-hand side rule. Clockwise will be negative and anticlockwise will be positive. Let us find the bending moment in the point B. In the point B, we have MB, which is acting in the clockwise direction, so that it will be negative. Let us find the bending moment at just right of D. MB is acting in the clockwise direction, so that it will be negative. RB is acting in the anticlockwise direction, so that it will be positive, and the distance is 2. For the bending moment at just right of D, we will get 65. To find the bending moment at just left of D, with this value, we have to add the concentrated moment 160. Since it is acting in the clockwise direction, it should be applied as negative. For the bending moment at just left of D, we will get minus 95. Here you can see the bending moment diagram. Now we are going to end this session. Thank you for watching this video.